questions on your homework?
Yes, actually. If I can remember where I put it. Oh, my finger.
We could do 30.
55. Wait, what did you say?
I said 35. I like 55.
55, the cone problem. Begin with a circular piece of paper with a 4-inch radius as shown in figure A. Cut out a sector with an arc length of x. Join the two edges of the remaining portion to form a cone with the radius r and height h as shown in figure B. Explain why the circumference of the base of the cone is 8 pi minus x. 8 pi minus x, circumference of the cone base. If we have this, we cut out this,
Mm-hmm. Then we have an oddly shaped pie. Instead of eating a dot, it's eating X.
alright, what's the circumference of the circle when it's not cut out? 8 pi, 2 pi r. So 8 pi, and we cut out x, so therefore our circumference of the base of the cone will be 8 pi minus x. So there's the reasoning why for that. Express the radius as a function of x. Express the radius as a function of x. Alright? So therefore, if my circumference is 8 pi minus x, and if we look at my cone here, alright, the radius of the base is r, so how do I find circumference? 2 pi r equals 8 pi minus x. So I get 2, I'm sorry, we're looking for r, so we're going to divide by 2 pi. Well, I can't think here. So we get 8 pi minus x over 2 pi. Or you can have 4 minus x over 2 pi. Okay?
So how do you know that the circumference was 8 pi? Again,
How do you find circumference? 2 pi r, what's the radius?
4.
4. Put 4 in for r, you get
8 pi.
8 pi. If we take this x away, we're left with 8 pi minus x,
Oh, yeah.
right? Express the height h as a function of x. The height h as a function of x. So if this is r, this is h, and I know this is 4, I have a right triangle, which states what? R squared plus h squared equals 16. Alright? So therefore this is going to be 8 pi minus x over 2 pi squared plus h squared equals 16. H squared equals 16 minus 8 pi minus x over 2 pi squared. And then you can take the square root. And we could simplify that down further if we wanted to, but I'm fine with that. And then lastly is to express the volume of the cone as a function of x. How do we find volume?
1/3 of the area on space times
V equals 1/3.
times the area of space times its height.
There's my R. And where's my H? Oops. Parentheses. Okay? Make
Yeah.
sense?
Why would it be 1/3 pi?
Because the area of the base is pi r squared. Oops, I forgot to square the r.
Ah. That's right. That's one. Circle.
Where do you find all these formulas and stuff?
From your head.
You may.
Will it keep all of them in your head?
You just gotta dig around a little bit.
My head,
Yeah.
there's nothing to dig around in.
Can't remember if there's anything. I thought there was something in the back, but I don't think there is.
Do you look in your geometry book?
Yeah, you can do that or just Google. Any other questions?
This class was meant to be taken with geometry.
It's meant to be taken.
After geometry, when you've learned everything.
Everybody good?
No, but okay.
Okay. I'll pass those forward, please.
I do have one.
Oh, go ahead.
So for 43 and 47, so in your, like, putting together a piecewise function, you're not graphing it.
Right?
So for the second line segment, so do you use, the point slope formula and use the point that it goes through on like the x-axis to find the y-intercept?
Yes.
Okay.
Yeah.
I actually had a question also.
Which one?
35. I don't understand. If you have vertical lines and you're doing vertical line tests, how is the curve of the graph a function? That doesn't make sense.
Well, again, remember for a graph to be a function or a the word left me now. A relation to be a function, what must be true?
That I don't know.
What must be true is that every member of the domain must only be paired with one member of the range. That means the x value cannot repeat. So if we use a vertical line test, which represents what?
The line,
But what does it represent?
the domain.
How do you write a equation for a vertical line?
X equals.
X equals. So the vertical line represents all your x's. So therefore, if it intersects the graph more than once, that means
There's 2 x's.
the two x's are the same. So they're repeated.
Wait, you mean the two
So they're talking about a vertical line test.
Wouldn't it be the two y values? Are
No.
the same x value?
Well, yes, but the x value repeated itself. So say for instance, if I have this graph in a vertical line test, well, what's the relationship of the x value here and the x value here?
Same.
They're the same. What's the relationship of the y value here and the y value here? So that means every y value, or the x value has more than one partner of the y value.
Okay.
Because this represents all the x's that are the same, different y's. Any other questions? Yeah, got away. All right, pass this forward, please.
I thought it was 45, not 55.
Huh?
I thought it was 43, not 55. Sorry.
Okay.
That's an odd number, 43.
The last like 3 problems are.
All right, you try to make sure you answer all the questions, don't leave any blank. For instance, just about everybody left 35 blank. Do not leave it blank, try to give me an answer, try to think it through, try to give an answer, so I can see what you're thinking.
I think
Nothing is
I
what
think
we're
we
thinking.
understood what the answer was,
Nothing is
just
what
we
I'm
didn't
thinking.
understand what the question was asking us to write.
Dad, we did put down what we were thinking. It was blank.
I know, but you can't do that. Don't leave it blank. All right, let's look at exponential. All right, here we have an exponential function, f of x equals a times b to the x, where b is my base, a is my initial value, and my x is my exponent. All right, it's my exponential function. We have a base, we have an initial value, which the initial value is a lot of time is my,
Sorry, say.
what is it?
No, can you say it again?
All right, my initial value is also what of my graph? What part of my graph?
X-intercept.
Nope,
Y-intercept.
the y-intercept.
Y-intercept.
Okay.
Yes. If you put 0 in for x, what are you left with? You're left with a,
I mean, yeah.
so that's my initial value. Remember when we talked about exponentials? We have population growth. P sub 0 equals 1 plus r to the t.
Mm. Not again.
We have continuous growth. We have exponential growth and exponential decay. How do we tell if a exponential is a growth?
Is it if the exponent is greater than one?
Not the exponent,
The initial value?
not the initial value.
The base.
The base.
Just go through all of them.
If the base is greater than 1.
Just don't want to stay up.
Doesn't want to stay up. Why is that? What are you doing to my tripod, Connor?
I didn't do anything to it.
There we go. Sorry, Wendy.
Boom.
There we
Got
go.
it.
How do we tell if it's a exponential decay?
If the base
The base
is in between
closer
0
to
and 1.
0.
All right, between 0 and 1. Okay, that's correct. Between 0 and 1. Remember, we use the e if it's compounded continuously. So if the interest rate is compounded continuously, we use the letter e to the RT. If we're dealing with half-life, my base would be 1/2. 1/2. So let's look at some examples here. Turn to page 26. Again, a lot of this should be review. Let's start with number 2 on page 26. Graph the function. All you're gonna do is show me the shape, state its domain and range. So number 2. Is this a decay or a growth?
Growth.
It's a growth. It goes through what points? I'm sorry. What's the shape look like? Remember a growth? An exponential? Looks like this.
That's right.
Yeah, I knew that.
My basic function is this is 1. Alright, always goes through 0, 1, and 1 the base, correct?
Yes.
We always have an asymptote at y equals 0. So the one that we're looking at what happens to my asymptote?
It moves up 3.
Moves up 3. So therefore, what happens to this 0, 1?
It moves up to 0, 3. 0, 4.
Goes to 0, 4.
Sorry.
Okay? And so this is a growth, correct? What's my domain?
All
All
row numbers.
row numbers. What's my range?
0 to infinity.
Now remember, what happened?
It's 4 to infinity.
Nope.
Oh, 3 to infinity.
3 to infinity. 3 included or not included?
Not included.
Not included. Look at number 4. Y equals -2 to the negative x minus 1. Alright, is this a growth or a decay?
Oh, it's a double negative.
Growth.
It's neither.
What does the negative exponent tell you? What happens? This is my graph. The negative exponent tells me to do what?
Negate the function.
What? Flip over the y.
Alright, the negative number function tells me to do what?
Oh, flip over the x. Okay.
So
So
this
it's
is
a
growth.
growth.
So we haven't started growing, correct? What's my domain?
All row numbers.
All row numbers. What is my range?
0, no wait. So it would be from -1 to negative infinity to -1.
Negative infinity to -1. Correct. Any questions on those two? Okay, number 6. Rewrite the exponential expression to have the indicated base. We need a base of 2. 16 with a base of 2 is what?
Is it 2 to the 5th? No wait, 2 to the 4th.
2 to the 4th? To the 3x?
So 2 to the 12th.
2 to the 12x. Alright, very good. Look at number 8, one at base of 3. 1 over 27 with a base of 3.
Well, that would be.
Negative.
It would be
3 to the
3 to
negative
the
3.
negative 3, right?
Correct. To the x. So my exponential would be
Oh, sorry, it would be 3 to the negative 3x.
alright, very good. Number 9 through 12, use a graph to find the 0 of the function. So we're going to use our calculator, graph it, and use our intercept button. Or the 0 button, 0 function. Okay, calculator, Connor?
What is the E button? Oh, is it in math?
Should be, could be in math or LN, by the LN button. Do you have the LN button?
It's good. Somewhere. I'm looking.
It's next to the number 4.
Is there an E to the X on top of that?
Yes.
Okay.
What are we looking for?
Looking for the X, the 0.
Wait, how do you find E to the X?
Should be right there by the number 4, LN. Should be right down top of
It
LN.
says.
Oh, okay.
Got it?
Oh, I didn't do it right.
No, you got it?
I do.
What do you got?
Should I show you?
No, just tell me what the 0 is.
Oh wait.
So second calc, 0, left bound, right bound.
Wait, oh, we're looking for the 0.
2.3, 2, 1.
No.
No?
Hi. Is it 1.386?
1.386 should be the correct answer. Find it, Grace?
Yeah, I found the button. I'm just like trying to put zeros now. So,
I gotta open your window, because you don't see it going across the 0. Okay, good, so make your X bigger, so maximum X, well, now you don't
Oh, I
need
did
negative
the
X
wrong
bigger.
one.
So make the maximum 10, yeah, now graph it. Alright, so now it crosses, now you go second calc, 0, and you left bound. And both to your right bound. Okay.
1.386.
okay, thank you.
Good, you got it, Caleb? Good, son?
Mm-hmm.
Is that a different one? Got it? What are you throwing it? Did you have it? No, you don't have the right graph. Go to your y equals again.
Did I put in the wrong one?
Yes. Should be e to the x minus 4.
Okay.
I don't know what you were looking at. Alright, turn to page 23. Look at number 23. Look at the table on the bottom of the page, prediction of the United States population. When we look at this, my base is always a ratio. If I look at, mark go. F of x equals 3 to the x. And I make a table, and I start at -1, that's 1/3, 0, that's 1, 1, that's 3, 2, that's 9. If I take the bottom number and divide, what's 1 divided by 1/3?
No.
1 divided by 3, right?
Oh wait.
What's 3 divided by 1?
3.
3. And what's 9 divided by 3?
3.
3. Now, that tells me my ratio every time, as long as they go down by 1. So when we look at this table, we got 1998, 1999, 2000, 2001, 2002, 2003. So we can find our ratio by taking the bottom number and dividing by the top number. So 279.3 divided by 276.1, we get 1.0116. 282.4 divided by 279.3, we get 1.0111. And keep on doing that. What's our average between all those numbers? We round off to the hundreds place.
No.
1.01.
1.01. And that's how we're going to find our base, right, of our exponentials. Now, to find my starting point, then usually I would want to pick a date for my starting point. So here they just say 1998, that is x equals 0. So therefore, my starting point, my initial value would be 276.1. So this exponential would be f of x equals 276.1, 1.01 to the x. And that's how I'm going to find my exponential with these graphs. Not going to use a regression on our calculator. Our regression on our calculator will get something close to that, but here we're just estimating off the table. So if we go back to page 26, we look at number 20. We want to find the population of Virginia. How am I going to find my base?
Divide the
Divide.
second y coordinate by the first y coordinate.
Alright, so we're going to take 7,000 divided by 6.901, then 7.078 divided by 7,000, then 7.193 divided by 7,078. So, Al, you do the first one, Connor, you do the second one, Caleb, you do the third one, Noah, you do the fourth one, and Grace, you do the fifth one. Alright, find the base. So Grace, you're doing the last two numbers. Noah, you're doing the fourth and the fifth. Caleb, you're doing the third and the fourth. Connor, you're doing the second and the third. And Al, you're doing the first and the second.
Is that for, do you,
Number 20. We got 1, 2, 3, 4, 5, 6. Here's Grace. There's Noah. There's Caleb. There's Connor. There's Allie. What do you get, Grace?
You divide the, I would divide the 2002 one by the 2003 one, or is it the other way around, right? It's just-
2003 by the 2002.
Oh, oops, okay. .013.
Okay? Noah, what do you get?
I did the wrong. 1.013.
Alright, Caleb, what did you get?
1.016.
Alright. Connor, what did you get?
1.01.
Alright, and Allie, what did you get?
Not 1.014.
Alright, so therefore my base would approximately be what?
1.01.
My initial value would be what?
The, well,
6901.
So there's ups and this to the x power. And there's my exponential. Make sense? Alright? Let's look at number 22. The population of Silver Run in the year 1890 was 6,250. Assume the population increased at a rate of 2.75% per year. estimate the population in 1915 and 1940. Alright, so we're gonna use this equation. We got P equals, what was my initial population?
6,250.
6250. What was my percentage rate of increase?
2.75.
We changed that to a decimal.
0.02.
Correct? So now we want to find out what was the population in 1915. Well, how many years past 1890 was that?
25.
So we put 25 for T and calculate. And then we want to find out what was the population in 1940. So how do you not calculate that?
Oh, don't you have to put, you have to find the zero, no, the
Put
zero,
50
the.
Now, if that's our population there, and we want to find the population in 1940, what do we want to use for T?
T would be.
50, correct?
Yeah.
And then, if I want to approximate when did the population reach 50,000, then I'm going to put this equation into y1. y2 would be y equals 50,000, and use my intersect method on my calculator. Alright, so everyone try that. Put those two equations in your calculator and find out when did the population reach 50,000. So using those two equations here. Make sure you open your window to see at least 50,000. And I would open my window to see probably 100 years. What'd you get, Caleb?
76 years, well, 76.7 years.
So round up to that, so 77, some of the year would be
1967.
1967. You good? Connor, you good?
Mm-hmm.
Wait,
You sure?
I think this is.
Mm-hmm.
Wait, how do you put it? X equals 50?
Y equals 50,000. And your Y2?
Yeah.
I wonder what's the best picture someone's ever drawn of that. You should try it.
Wait, this is,
You should try to draw.
your one curve is wrong. The Y equals 1.
Couldn't do
Oh, whoops. I didn't-
Yeah. There you go.
This one was mine.
There you go.
So you know Eli Johnson, who used to live here? I saw him at the mall yesterday.
So, lucky you.
Did you see there? I don't think he saw us, but like I saw him like right as he walked by.
Is this supposed to jump to the second line?
Is that?
Oh, yeah.
Yes, it is.
Yeah.
Let's look at number 26. You good?
Yeah.
Doubling your money, determine how much time is required for an investment to double in value if the interest earned is at the rate of 6.25 compounded monthly. So we're going to use this equation. Alright, if we want to double, if we take this and put it over here, take it over there, what would be my result?
2.
2. Doesn't matter what numbers you put in there. If you can't remember that aspect, then just put numbers in to test it out. This would be 1 point, what was my interest rate?
6.25.
So 1.6. Oh no. Oh yeah.
And remember, if we're doing it monthly, we have to take that interest rate and divide by 12. And take this time and multiply by 12. So now we're solving for t. What's 0.0625 divided by 12? You got that, Connor? 0.0625 divided by 12?
0.00521. No, it's approximate.
Right, do we remember how to get out of the variable, out of the exponent?
Don't you
Use
use
a
the
ln both sides or something like that.
Alright, and solve for t.
No.
So we got ln 2 over 12, ln 1.00521. What do we get?
11 years. 11.12 years.
So 11.12 years. Okay?
Mm-hmm.
Let's look at number
For those, do you want us to solve it without graphing it?
You do it either way. Do it either way. Look at number 32. Suppose that in any given year, the number of cases of a disease is reduced by 20%. If there are 10,000 cases today, coronavirus, just kidding. Your homework on page 26, 1 through 39, every other odd. All right, sanitize your desk before you leave, please.